This is it. This is where it all happened. And now it's over. Yeah, do you want to just start with a little intro of just kind of your background and how you got involved with the nano?
Sure. Well, I've been working as an electrical engineer now for almost 15 years. Ever since I got out of school, was in the military industry. And I worked with a friend of ours, Martin, who put us in touch, saying you were looking for someone who can help you out with some circuit design. And I thought, hey, that sounds interesting.
And how badly do you regret that?
Now that it's over, not at all. Now that we've passed that critical line, we're good.
Good. And how is this different than what you're used to in the military industrial complex?
Well, in military, there's very, very strict requirements and guidelines and specifications and big budgets. And so you put a lot of work into part selection. You're not restricted usually when it comes to part selection in terms of cost or sources. And nano, on the other hand, because we don't have massive big companies buying this thing, it's just the do-it-yourself home hobbyist. We have to manage the costs, and there was also the size that was a factor, right? In most welders, they could be big tabletop things, but we wanted this thing to be handheld. So the big challenges with the nano was keeping the size down and the cost low. And for that, I wasn't used to, we had different sources. You were finding parts all over the place for much cheaper, right? And a lot of times we were restricted to certain parts because we had to buy from specific vendors because they're the ones who were building our prototypes, right?
Yep. So JLC PCB.
Exactly. So I didn't have as big a range of choice when it came to selecting parts.
Yeah.
Yeah.
No, it's a good thing we went away from them for the core board and the DCBC, because that would have been impossible.
That's right. Yeah, it gets trickier.
Yeah, for the timer, we managed to do it, and same with the battery board. So that saved massively on cost. But
yeah.
This is it, the history of the nano. The nano started off with this little two-part board, which is no longer connected. It looks like crap. It's covered in Kapton tape and liquid electrical tape, but it worked. It gave me a pulse, and at the time I didn't even have a power source for it, but it gave me a pulse, and that's all I needed from it. It had proved that it could do the basic job. Now, what job was that? Well, I mean, the obvious answer is, spot weld, but the second version of the nano really points to where we were heading with this, and it was to have a very narrow and long device, so we could build these jigs to change the way batteries are assembled. Essentially, automation relies on expensive robotics, whereas we were going to work with inexpensive, hot swappable, almost disposable welding apparatus set up in giant jigs that could do hundreds of welds at a time. And that required a stable, incredibly powerful power supply, which led us to using supercapacitors. And we tried all sorts of things. We tried to keep it as small as possible at first, and we've seen it succeed with smaller ultra cap banks, but ultimately we needed the higher voltage to overcome the resistance of the form factor we were working with, and we needed the capacitance to avoid the voltage sag that would prevent us from being able to run it properly. So, you know, something like this would have been amazing, but really what we ended up with was this 3 capacitor device. So this was partially hand assembled, partially assembled for us, and again it worked, and at this point we already had some semi-viable power supplies, and we were able to weld. So we knew the device not only worked in principle, but in practice as well. And so we moved on to beefing it up and bringing in extra features. So the costs of prototyping were starting to add up, and we needed a way to fund it. So we decided to make a consumer device, because now we had this tiny little device that required no extra external outputs. You know, you had your power supply, which was the super caps. You had your device. You didn't need anything else. And I remembered when I started, I was very frustrated because I needed a battery to run my first battery spot welder. So this was meant to address that issue. The other thing we needed was to move up to 6-ounce copper boards. These are incredibly thick and heavy, but ultimately the form factor grew too big for what we were initially intending for it. It was really reflecting the needs of the user base we were targeting. But again, it worked, but not without its problem. The added complexity of having this charging circuit here started creating issues. We also started having issues with MOSFETs blowing because we were sending too much power through them. And, you know, because we moved from 7, 5 on one side, 2 on the other, to 5. Our users were adding external power supplies that were more powerful than the caps. James, who we dubbed James the Destroyer, one of our testers, was very prone to doing this, and it gave us a lot of great information, but ultimately we knew we had to redesign it. At this point, we had actually bought a pick-and-place machine to bring the cost down, and the reason is not to actually build them ourselves, because as you can see, you know, I wasn't necessarily very good at it. The idea, though, was to be able to tell the assembler, like, listen, you know, with some pictures, thanks but no thanks, your price is too high. And sure enough, the price of a batch came down by more than the cost of the machine. Not a prototype batch, but a full production batch came down by more than the cost of the machine. So the machine played its role. We sold it off, actually. We moved on. We added back 2 more FETs. We externalized the 18650 charger, so we had a battery on the other side. And I'm missing all the cases here because in closing repowered batteries, we lost a lot of prototypes. Actually, we're missing steps here. Even with what I'm showing today, we're missing some steps, and we're missing all of the prototyping of the cases. But ultimately, this is what we sent out the first time, and it was a mistake. I felt horrible. The feedback came back very quickly. You know, this device is not reliable, it's blowing, and we didn't know why, and we had to figure out why quick. So I immediately promised everyone a replacement once we had settled out all the issues, which we are still going through, of course. But ultimately, this device form, this iteration was a failure. And we moved on to a potential bus bar setup where we could use a cheaper manufacturing and use bus bars, but it just wasn't coming out nicely. So we quickly abandoned that and moved back to having thicker copper. But we were still coming up with issues. But because we had moved to the Nano 2, which allowed us to separate out every little part in 6 boards instead of 3, we were able to really focus in on the issues and fix them one at a time. And in fact, had we not done that, although it did add some production time because we had to do a full redesign, had we not done that, we would have run out of cash, because each iteration beforehand at this stage was nearly $1,000 of prototyping. Whereas when we moved here, the most expensive part costs about $350 to prototype, and the cheapest part costs about $35 to prototype. So being able to spread it out like that really made it viable. And finally, we got to where we were trying to get to from the beginning, a small compact device that actually works reliably, comes in at the price of a cheap, just generic spot welder that is not really any good, except that it's all made with brand name parts. It's made to last, and it's made to be serviceable.
Hey, Stephen, how are you?
I'm good. And how are you, Julian?
Well, a month ago I had a budding battery business and all my teeth, and this month I have neither. But otherwise, I'm doing pretty good.
Okay. Yeah, a lot of people are facing that in these days. So
So I was going to start by asking you to introduce yourself, but you know what? I think I'm going to go ahead and do that. So we kind of met randomly. I found you on Google Maps, actually, of all places. I found your business there. And the Nano had just so little marketing presence that your work on the video ended up having a tremendous influence on it from our side. So which is why I thought it was very important to get your take on this for this little documentary. So why don't you explain to us a bit what your role with the Nano was from your perspective?
okay, well, I came into it after the course the Nano was almost completed. And so I wasn't involved in any way in terms of the construction of it. But I came in when you were actually at a point where you're trying to raise money through a crowdfunding program. And what I tried to do is to figure out, okay, who is your target audience? Who really wants to buy something like this? One of the big mistakes of any advertising is to be too general, because a lot of people are not interested in your products. You've got to find those people. And so what I did was I first found out, I knew nothing about spot welders. So you gave me some direction in terms of where people are who actually are interested in spot welders. And the thing is, you always have to find is, why do they want a spot welder? What is missing in the market? Or what are the kind of the opposition to buying things in the market? And what we found very quickly, going through the various forums and so forth, that, there was very expensive spot welders out there, but it was too expensive for the do-it-yourselfer. And what was available at a lower price, usually, well, the word junk came up a lot, that there was just nothing out there that fit their need. And also it came out that the shipping issues was a big issue. You would order it, it would come from China, and it would take 3, 4, 5, 6 months. So we thought that was probably the two most important things we should look at, is that it was a quality product at a certain price that was available to you pretty quickly because it was made in North America. And then we put into it what recognizes that do-it-yourselfers are kind of a self-identified group at times. So we, tailored the commercial along the line of this is for the do-it-yourselfer. It's for you, the do-it-yourselfer. So it helps to create a sort of identity to the product as well. And I guess it worked out well because you got a good return on it.
Yeah, and it's funny because all those points, such as getting it quickly, with all the iterations, ended up being pushed back about 6 months. But that's kind of the nature of Kickstarter sometimes. But moving forward, we'll be able to kind of deliver on that, because now everything's kind of ironed out and we can get them, spun out faster. So how did you perceive the project when you came in, and how did it influence how you structured the ad? I think you've kind of touched on that already, but.
Yeah, but I mean, what I saw was that you knew the product really well. Like, it was a good product. It was fundamentally a good product and it filled a need. And I wasn't too sure at the time that you really knew exactly how to reach your market. I think you were reaching it, but I didn't get the impression you knew exactly why you were reaching it. So so this commercial was tried to fill that need. It was aimed at those people who would be probably buying the spot welder, and that's a very specialized group. And I think you were able to identify, once you got it out there and you got the news out that this product was going on the market. The commercial just made it very, very clear what the product was. There was no confusion there.
All right. And again, your first answer was quite thorough, so we've gone over this a little bit. But as a non-technical user who is now working alongside the project, what were the key points you wanted to get across in your video? You've already mentioned kind of the stability of the product and the availability, through a North American-made product. But how do you convey, how this is useful in a video in such a short clip?
That's always a good question. And we struggle with it when you're trying to create it. I think we just had to hit certain points really quickly. You had, I think it was a minute and a half. I can't remember exactly, maybe a minute and a half. So you couldn't really spend a lot of time focusing on that. But we just basically showed it. One of the advantages is you are a do-it-yourselfer yourself. So people could identify themselves in you. And then you just showed the product. And there's a couple of things that you showed how quickly it did the spot weld. And I know nothing about spot welding, but to me it looked like it did it really quickly. It had enormous amount of strength. We went out and this was your suggestion, that we spot welded something, tied it around the back of a car and pulled the car to show you how strong it was. So there was sort of proof on the page. So that's kind of the things that we did. We also found that we thought it would fit into a scene on TV kind of commercial, which is always very rapid fire, get to your points quickly, move on. I think that might have played a role as well. It was a format that's very efficient.
All right. Well, thank you. I don't think the project would have launched the way it did without your support. And once again, thank you very much for your involvement with us.
Well, thank you. You were great to work with. It was terrific. Thank you.
All right.
So when we receive a core board, we still have some work to do. The first is the control board. So we have to clean up the edges, just because the company we use it's JLC PCB for this one, just because it's such a simple board. It saves us a lot of money from going with a higher quality provider. We put the trim pot. Usually I can see what I do better because I have my glasses on. And we trim it as flush as possible because we're going to have to put this tape after, this insulating tape. This capacitor serves to stabilize the timing circuit. And it's going to tuck away in the back of the nano. And then this insulating tape is going to make sure that none of the contacts touch. The next part we install, which are the heat sinks. And that's a core board. Next is the capacitor and what we call the power board. So the power board is this one here. It's made up, there's already the switch. I don't have any left without the switch and the I forget the name of this board, but it's the control circuitry. It's an off-the-shelf part. It's for charging the lithium-ion battery, if you have one. On this board we have the control circuitry for the soft start, the LED indicators, which we can't see anymore, but we've upgraded everyone to the LED display instead, so it doesn't matter, and the reverse polarity protection. And then on it goes the DC-DC board, which we designed. This one we get made at the higher end facility because the parts just aren't available at cheaper assemblers. So it does bring the cost up a bit, but it's worth it. It's one of the more complex parts. And so this makes sure that we get the correct voltage for the caps. We keep it just under 9 volts just because it's safer that way. Once again, we have to trim the pins flush because this is where the 18650 holder will go. For this demo, I'm not actually going to install one because I'm out. On the SuperCat board, we use an XT60 to mate to the to the core board, and we trim the back just so that it fits flush. This is going to be a bit more awkward because I'm trying to display it. And then we have the XT60 in the back for rapid charging with a direct DC power supply. We have a 2-pin header for the fan. And we have these insulating tapes that we laser cut for the backs, just in case something were to come loose and fall. We just want to avoid, large metallic surfaces where there could be a potential short. We don't have any reason to believe it'll happen. It's just we have the tools, we have the material. And lastly, the little LED display just goes and connects right to the back here. And I know I just said lastly, but I actually forgot. Of course, without this, we can't charge it up. So the way we made these is we just have just the shape of the board with exposed pads, and then a mating hole in the cap board, and the two come together. Again, this is not very elegant because I'm not at my usual station, and I'm trying to display it more than getting it in a handleable fashion. And that's a cap unit. So there's actually a lot more assembly time than we'd anticipated. And it is killing the economics of the device because the labor isn't cheap. So we are trying to, streamline this process, but for the time being, it is what it is. What was the biggest challenge? The redesign. The redesign was very much worth it. It brought the device to where I was really imagining it in terms of size, in terms of usability, in terms of serviceability, and in terms of cost. But that came with a pretty scary period. You know, where I was worried. I was genuinely worried for a while that we wouldn't be able to deliver. That was my biggest concern. What would have happened if we had not done the rebuild? Actually, without the redesign, I don't think we would have been able to iron out all of the bugs the way we did, because by having everything separate, we could really find out, you know, which parts were interacting in which way, and it really allowed us to tweak and fix what needed to be fixed, and only cost us, you know, rebuilding that specific subcomponent. Without it, this project would have probably died, and we would have run out of cash. What impact do I hope the device will have? I'm hoping it'll make it easier to get started without getting ripped off. The core kit we were selling on Kickstarter was still a bit more expensive than what I wanted, but with the redesign now, you know, this core part, this welder, should cost about $20 US, because most of the cost has been moved over to the caps. So buying the whole thing, that won't change. I mean, the Kickstarter price was still good. In fact, the price would probably have gone up a bit, just with everything going up these days. But it should be a, you know, not a heavy-duty device by any means, but it should give people a way into the hobby, without necessarily waiting 3 to 6 months for something to maybe or maybe not come in from China, and at a higher quality level. You know, not to knock them too much, but the challenge wasn't making it cheap or making it work. The challenge was making it work for cheap. You know, and by work, I don't just mean that it can do it once or twice, but I mean that it can do it repeatedly and reliably. And that was the real challenge of the device, was being reliable for cheap, not welding for cheap. Welding for cheap, there's plenty of options, and they're garbage. There, I said it. And then there's plenty of really good options too, to be fair, but they're more expensive. And yeah, they just are. What's next? The Titan. So if this project's goal was to be reliable and inexpensive, the Titan's goal is to bring in commercial level features and reliability and ease of use that doesn't really exist yet. Without concern for the price. That's not to say we're trying to keep it a tenth of the price of the entry level commercial machines, but it's going to be up there in price. We have the nano for the entry level stuff. If you're looking for a heavy duty, non-stop, everyday workhorse, then the Titan is going to be that. Without needing to kind of tweak or figure out which battery you should be using, or none of the variance that happens between machines either, which is part of the brilliance of some of the existing options in the hobby market. Is, everything is relative to the machine, but we want to build a machine that's truly standardized so that there's no tweaking. There's no variance. When one user has a certain configuration that works, they can share it and everyone can use it. And we want to program those into the firmware, actually. So that'll be cool. What that means is, you know, if you're doing 0.1 millimeter copper, you set the machine to 0.1 millimeter copper, not whatever settings it might actually be. And we're going to rely on testing, but at first from us, but then eventually from the community to get the best settings. Because there's also going to be a manual mode for people who do want to experiment. You know, help us improve it. But where did the idea for the Nano come from? The idea for the Nano actually came from repowered batteries need for an inexpensive, affordable, modular welding device. So the core board, really. And the idea was to have that set up to a gigantic power supply and have an array of small welders set up for essentially instant welding of entire battery packs. It addressed a bunch of different things that kind of annoyed me about existing welders on the market, so I decided a way of funding our R&D was to offering it as a consumer device as well. Why did we go back to 3D printed? There were issues with our cast option. Essentially the price tripled between the time we got our first quotes and the time we actually tried to order them. So with a tripling of the price and the added risk of not knowing what the outcome would be, because we had never cast these parts yet, it wasn't worth risking that much of the project over a vanity point, essentially, because we had already, like, these models were optimized for 3D printing for the prototyping process, and we had good results, so we went with something we knew worked instead of something that was maybe a little nicer but might have tanked. So at the end of the day, it wasn't just a price thing, because the 3D printing actually cost not so far from the more expensive quote for the casting, but the problem with the casting was that there was no room for a do-over, whereas 3D printing has plenty of room for do-overs because they're all one-offs. Was there any point where you wanted to give up? Yep. November 2020. That was the hardest part for this project. The last big expensive prototyping was sent back in November after it came back faulty. And that was several $100. We're talking like $600 or $700 US prototyping round. We couldn't sustain redoing it that many times, so when that one came back faulty, that was tough. Would I do it again? Absolutely. In a heartbeat. This project will have cost money at the end of the day, I think. Not even 100% sure, but it was an amazing experience. I met a bunch of amazing people. It was great.